All right. Good evening, college algebra. I wish I would have given you the next homework, but didn't foresee two back-to-back AMI days. So I guess hope you're enjoying your 5-day weekend. Doesn't make my job any more stressful or anything. Ha ha ha. Well, anyway, so a lot of y'all did pretty well on the Google form, but a lot of y'all still haven't answered it. Now, my AMI assignments could be much harder if I really wanted them to be, but I feel like I'm giving you guys a break on that. But still, about a quarter of college algebra students still haven't filled out the free questionnaire form. One of them was literally just putting your name down. They're quiz points, and quiz points are harder to come by. So, you know a friend that hasn't filled out the Google form. I'm still accepting the one from last time. The other two I've already closed off. Then hit them up and let them know. I'll still accept it. Now, with that being said, hopefully there's a lot more attendance on this one, because this is one of the most important sections that we're going to hit up with polynomials. And in fact, we should be hopefully going faster paced, but I feel like we're on a strict time schedule, so we kind of can't just slow down, or else I would have done more with the graphing stuff. But we'll go through the graphing stuff hopefully when we get back on Wednesday. Then you can then ask questions. Anyway, let's go through. I think it's called 5.4, but I labeled it wrong. It should be 5.5, and that was all on me. But it's the solving polynomial stuff. I want to hit up at least 3 of these examples: number 2, number 12, and number 13. Now I encourage you to do more of them. I have them all filled out and try them on your own, and then check your answers. But this should be a very, very straightforward section. We actually did a bunch of these back in quadratics unit. We've solved so many quadratics, and these are just the same, only a little bit more nuanced. So, but it should be relatively straightforward. Anywho, you'll have 2 questions to fill out in the Google form. I'll tell you them throughout the video. So let's go through on number 2. So we got 4x cubed minus 7x squared equals 3x squared. So in order to actually solve these, shocker, set these equal to 0. We've been setting stuff equal to 0 for the last 2 months straight. So first, let's combine some like terms and set it equal to 0. So 4x cubed stays the same. And then subtract 3x squared over, set it equal to 0. So now you're going to be left with minus 10x squared, 0. And then factor out any common factors that they have. Well, 2 goes both into 4 and 10. And you can also take an x squared out too. And then swing out the rest of it. So then you got 2x minus 5 left inside. And then, now that we got that out of the way, we now set both of these equal to 0. So 2x squared equals 0. And then divide by 2. So then x squared still equals 0, because 0 divided by 2 is 0. Take the plus or minus square root. And the plus or minus square root of 0 is 0. So we have x equals 0 as one of our answers. Now, why would that work? Well, if you plug it in, 4 times 0 minus 0 is equal to 3 times 0, which is 0. So that's what works. And usually, they're going to ask what the multiplicity of the 0 is. So that would be multiplicity 2, because we had a 2x squared. The reason why it's multiplicity 2 is because of the square there. And just like the multiplicity of graphing them, if we were to graph this bad boy out at x equals 0, it would bounce off either up or down, depending on what happens before it. And in fact, we could probably actually graph this if we wanted to. And I'll give you an idea of that, because I know that was one of the main things from the Google form with questions on, was a little bit more of the graphing stuff. Anywho, let's finish this off. We also have this. So 2x minus 5 equals 0. So 2x equals 5. So x equals 5 over 2. And that's also one of our solutions. So we have x equals 0. And that would be multiplicity 1, but you don't really have to say that. It's usually just kind of assumed. And then you have x equals 0. Now, That's just solving polynomials in general. It's extremely similar to solving quadratics, which we spent literally a month on and took it on our final. You guys did decent with that. Now we're going to have 2 more examples to go through. But let me ask you question 1 on your Google form. What is the difference between zeros and x-intercepts? If you Google it, you're not going to find the answer. There's a lot more nuance to it. Hopefully by the end of this video, it's going to be a lot clearer because, well, what is an x-intercept? And what is a solution to a polynomial or a zero? Solutions and zeros are identical. All right, keep that in mind. That's going to be question 1 on your Google form. All right, moving on to the next one. 2x to the 6th, this is number 12 from the notes, minus 10x fourth minus 48x squared. So, firstly, it's already set equal to 0. Makes our life easier. But now we actually have to factor out the common factor from each of those 3 terms. So, funny enough, it's the exact same GCF as the first one, which is actually kind of ironic. So you can actually factor out 2x squared once again. Okay? And now you just got left with x to the 4th here, minus 5x squared, minus 24, 0. Now, before you split it off, make sure everything is factored out. So here, we could actually factor the inside. Now, it's factored in just like a normal polynomial, right? This is just a normal quadratic. So it's different signs, bigger number gets your minus. So here we got x minus, and then we got 8 and 3, because 8 times 3 is 24, 8 minus 3 is 5. X minus plus 3 equals 0. But remember, this is next to the 4th. So you got to throw a square on both of these. So now I got x squared minus 8, x squared plus 3. And now we set these equal to 0. So 2x squared equals 0, just like before. X equals 0, and if you have any questions on that, it's literally right there. Then usually you'd want to say the multiplicity, but for here, I just don't have the room, so I'm not writing that out. Then you got this one here, so x squared minus 8 equals 0. X squared equals 8. X equals plus or minus the square root of 8. But that would be almost correct. You'd be losing a half point because we're in mature college math. We have to simplify our radicals down, make it into a 2 root 2 plus or minus 2 root 2. The perfect square that goes in 8 is 4. Split it up. Yeah, be on the lookout for those. I will be nitpicky about it. I have to be nitpicky in MACC standards. And then you got your x squared plus 3 one. So x squared plus 3, 0. X squared equals negative 3. So x is plus or minus. We have a square root of a negative, meaning we have to throw an I out. And then leave it as a square root of 3, because square root of 3 has to be just kind of in there. And there we go. So you have 1, 2, 3, 4, 5 solutions here. Because you got 2 here, because that's a plus or minus, means you got 2 solutions. One's positive, one negative. 2 here. But I argue you only got 3 x-intercepts. You can't really graph imaginary numbers, can you? Not yet. That's pre-calc. You don't want to talk about that. That's polar parametric coordinates. It's too much for this class now. But that's equation or example number 12. I still want to go through example 13, but just so people don't skip to the end of the video, find question 2 out. Question 2 is going to be, this is a tough one. I could make it into another math question just to spite you all, but I already know that some of y'all are just going to skip through it and then ask your friends for the questions. But regardless, I still want to make question 2 kind of fun. So as I'm erasing, I'm going to try to stall for time here. I'm actually going to post, I feel like I'm too easy on you guys. I got to challenge you guys more. I understand your situation, but let me just post with this Google form. So if you've been watching the video, this is going to give you a lot more context as to why I'm posting on top of the Google form. Pre-calc notes number 1. I want to just share what the suggested notes for day 1 only, meaning I'm going to post the notes for 1.1 pre-calc notes, because right now I'm using Algebra 2. I could be a lot harder. Now imagine going through these pre-calc notes that I post with this in one single day. And also day 1. Not even day 1, semester 2. Day 1, August. Imagine going through that. And hopefully that's going to give you a little bit more appreciation for me being lenient with you guys. But now, question 2 is going to be, how's your math doing? In other words, have you felt like you've learned a lot of math this year? And I'm not going to be heartbroken if you say no. This has been mostly reviewed because it is from Algebra 2. But hopefully you get at least a little bit of a deeper understanding of the stuff we're going through and why. If I haven't taught you anything new this year, then I failed. But if you feel like you've gotten better at math since the very beginning, good. And plus, I still have all your tests too. And there's a reason why I have it. And I haven't forgotten, so you'll see at the end of the semester. 3x to the 4th plus 2x squared equals 8. So that's going to be example number 13. I've been hiding it for most of the time. So, but this will be the last example we go through. What's 2x squared? Actually, I'm going to give you a question 3. So actually, there's going to be 3 questions on your Google form. Question 3 is going to be, what's been your favorite memory in math class this year? Yes, that is question number 3. What's your favorite math memory from this year? I'm curious to see what fun memories you've had this year. If you've had any, you've just been sleeping the whole time. Ugh. Okay. Anyway, let's just solve this and then we'll be done. So here, we got to set this equal to 0, per usual. And here, it's kind of guaranteed. Well, here you could just do the quadratic formula to find x squared, but it's kind of cherry-picked perfectly for this very specific method we use to usually solve these. It's called the slip and slide. Hopefully, you know how to slip and slide at this point. Multiply the first and back number together. And then factor it like normal. So different signs, bigger number gets your plus. So x plus 6, because 6 times 4 is 24, and 6 minus 4 gives you 2. And then x minus 2. Now, you want to slide the 3 back, and also these are x to the 4ths. So you got to throw a square on there too. And then divide out any common factor you may have. So here, this turns into x squared plus 2. This stays as 3x squared minus 4, root 2. And then solve for both variables here. So x squared plus 2 gives you 0. This part right here. So now you got x squared equals -2. And x is equal to plus or minus I square root 2. Because it's the square root of an imaginary, so you got to throw an I in there, and root 2 is irrational, so you got to leave it like that. And then you got this part right here. So this becomes a little bit crazier. Wait. Ah, I knew it. I was getting ahead of myself. I was solving for before. This is 4. So if you're like, wait a second, Zola, what are you on? Well, yeah, good catch. That's supposed to be 4, not a 2. Anyway, I'm too lazy to redo this video, so I knew what it was going to be at the end, so and you'll see why I'm left as that. So now let's solve for this part. So 3x squared equals 4. So x squared equals 4 over 3. And here, you got x is equal to plus or minus the square root of 4 over 3. And remember, with radicals, you can actually break up the quotient a little bit. So plus or minus the square root of 4 over the square root of 3. So now you just got plus or minus 2 divided by root 3. And there you go. And typically we'd want to, I guess, rationalize the denominator is what it's called. So you might see the answer, especially if you put this in the photo math or something like that, as this is the answer. And that's also correct too. So either way, yeah. Anyway, fill out all 3 of the questions on the Google form. Peace out.